Leonard. I'm the project manager and systems engineer of the BEAR project. I'm also a research assistant at the Chair of Space Technology, and I'm responsible for the management of the system, the overall system architecture, and the autonomy.
Hi, I'm Michael. I study computer science and I'm mainly responsible for the BEAR manipulator.
Hi, I'm Tobias and I'm studying space engineering at the TU Berlin. As part of my bachelor thesis, I'm developing an alternative gripper for the BEAR Rover.
Hello, I'm Felix. I'm studying mechanical engineering and I'm the mechanical systems engineer for the BEAR Rover. I'm mainly responsible for the design and the assembly of BEAR's chassis, as well as the programming and the integration of the locomotion control.
Hello, I'm Sebastian. I'm research assistant in the Sierra project, which is an interdisciplinary project for radio and robotic applications. And in the communications part, as ham radio operators, we're developing the communication system for the BEAR project.
Hi, I'm Friedrich. I'm now for 2 years part of this project team. I support the project management and moreover, I design a LiDAR platform for the new rover.
Hi, I'm Max. I'm the drill engineer for the Space Rover projects. I study aerospace engineering at TU Berlin.
Hi, I'm Christopher. I'm studying in computer science and as part of my master thesis, I'm working on networking and communication with our rovers.
Hi, I'm Norman. I'm studying electrical engineering in the Masters now. So this is the main electrical power system of the rover. The battery is connected up here and then it goes through a fuse and through a relay and then to the various DC-DC converters that break down the voltage for the various subsystems. This is the power panel, which is connected to the electrical power system, and it controls the relay, so it can basically completely isolate the battery or just cut power to the various subsystems. Where right now you can see that the rover is enabled. With this button you can disable the motors, so only the motors get no power and you can do debugging with the rest of the system. And that here just switches off the disconnects the batteries and switches off the rover, and there's going to be the emergency stop button right here where you can just hit it and it also triggers the relay in.
So, I wanted to talk about why we actually participate in the European Rover Challenge. The main reason for us is, first of all, that we are actually having the Space Rover project here at the Chair for several years now. And our main objective is to conduct research for planetary mission scenarios. And the way we want to do this is basically by competing in these kind of challenges, because they give us a great opportunity for a complex mission scenario, and they also give us the same kind of requirements and constraints one would have in an actual space mission. Our overall approach is basically with BEAR that we have a very versatile platform for very different complex tasks. So on the one hand, of course, the main objective with BEAR must be to be able to navigate the terrain, and we went with a four-wheeled chassis which is able to drive across slopes of up to 30 degrees, but it's also able to climb up smaller obstacles. So with our other rovers, we actually went with a rocker boogie chassis, which is almost the standard for planetary rovers for climbing over obstacles and navigating difficult terrain. The reason why we didn't do this is because we wanted to place the drilling motor or the drilling platform right in the center of the rover. So when it is drilling, it has a very stable stand on the terrain, and it won't actually interfere with the stability of the rover while drilling into the ground. So we have the main electronics compartment, we have the sample retrieval device, and we have the manipulator. And the fourth part, of course, is the chassis. And this gives us a very high modularity. So what we were able to do is to basically assemble all the subsystems before we started to integrate. And then we would start testing the subsystems already before they are actually integrated into the actual rover. Another important part of the rover, of course, is its camera mast. So we want to do all the navigation during the challenge autonomously. And for the navigation to be autonomous, the rover needs to have a very good perception of the environment. So this is our main approach for the BEAR rover.